The first equation is your constant equation. So remember, if you remember from when we did linear functions, so we're starting back from September that we're remembering, it was anything that's a horizontal line. And so again, the name of that function is a constant. The equation is y equals c. C is just some number. It's the number that it hits along the y-axis. For this particular problem, what is the equation? Y equals 2. So I'm going to give you the generic, and then I'm going to give you the specifics for this one as well. The domain for a constant will always be negative infinity to infinity. The range will always be just whatever that number is in a bracket. So the range for the specific problem is 2, because all of the y values are 2 for that problem. X-intercept, unless it happens to be the equation y equals 0, so that's the exception to the rule, you don't have any, because it doesn't ever hit the x-axis. The y-intercept is always going to be 0, comma, whatever point it goes through. So for this one, it would be 0, 2. I want you to write x and y intercepts as ordered pairs, because it's just kind of getting you started. This is how you're going to be doing it next year. And then the end behavior, what are the ends doing? What y value are they going to? Well, because it's a flat line, they're staying on the same y value. So for this, the end behavior is just whatever that constant value is. So both of these are going to 2. All right. What is this second one an equation of? A linear. It's an equation of a line. So that's a linear equation. Equation of a line that has slope of 1 and goes through the origin is y equals x. If I'm talking about what it looks like for the transformations, which we really don't do transformations with linear, but slope and y-intercept changes, that's how you know is it's based off of y equals mx plus b. The domain always of linear and range is negative infinity to infinity. If a domain or a range is negative infinity to infinity, nothing's ever going to change that. It will always be, no matter how many transformations I have, will always stay the same. Okay? The x-intercepts and y-intercept is 0, 0. And then the only way that would change is if I had any shifts left, right, or up or down. My end behavior, as it goes to the right, started off with the left. As it goes to the left, going to the left, it goes down forever, so negative infinity. As it goes up to the right, it goes to positive infinity. All right, this next one. What is that the equation of, or the graph of? A quadratic. Parent function for a quadratic is y equals x squared. If I was talking about what the transformation one would look like, that one would be what we called vertex form when we did quadratics. If you want to write that down, you can. I'm not going to ask you to know that, but when we get to transformations, that's the form that we're going to be using when transformations, which is going to be the next class period. What is the domain of every quadratic? Negative infinity to infinity. The range is bracket 0 to infinity. So the domain will always be the same, but the range will change based off of 2 things. A reflection across the y-axis and or a shift up or down. That's what could change your range. X-intercept and y-intercept is 0, 0. End behavior, both ends going left and right are positive infinity. When you look at end behavior, when it says going to negative infinity, that would be your left end, and the one to positive infinity is your right end. All right, anyone know the name of the next one? Square root. Kind of looks like a square root, doesn't it? Kind of has that shape. It's kind of a little memory trick if you have trouble with that. The equation, y equals square root of x. And of course, if we were talking about with transformations, that would be y equals a square root of x minus h plus k. Domain is bracket 0 to infinity. Range is bracket 0 to infinity. So what would affect the domain would be a shift left or right. What would affect a range would be a reflection across the y-axis and then a shift up or down. In pre-cal, we will talk about reflecting across the y-axis. We're not going to do it much. We're not going to do it in here at all. Okay? X-intercept, 0, 0. Y-intercept, 0, 0. End behavior is not applicable because the graph does not go to negative infinity for x's, but as it goes to positive infinity for the x, it's going to go up forever. It's going to go really slowly, but it's going to go up forever. So it's going to go up to positive infinity. Next one. Who remembers what that one is? Absolute value. Well, absolute value looks like a V. Remember, that's the one with the bars around it. If we were talking about with transformations, it would look like that. The domain is negative infinity to infinity. The range is bracket 0 to infinity. Quadratic and absolute value are very similar, with the difference that absolute value comes to a point at its vertex, whereas quadratic is curved. My x and y-intercept are 0, 0. And then both negative x going left and right is positive infinity. The next one. We've talked about this one once or twice, but we haven't done a lot with it. This is a cubic. It is y equals x cubed. You'll notice it kind of has this little curve thing going on. Curves right there at the origin. The domain and range are both negative infinity to infinity. By the way, make sure on anything that you turn into me, always use interval notation for your domain and range. That's the only thing that I'm going to accept, okay? X and y-intercepts are 0, 0. Oh, sorry, I forgot to give you the transformation one. Y equals a, x minus h cubed plus k. That looks very similar to the quadratic one, so you would have to pay attention to make sure you look at what the exponent is. This looks kind of like a quadratic, except that this part is reflected across the axis. It's similar in that respect. End behavior, the left end goes to negative infinity, the right end goes to positive infinity. Okay, this one looks like the previous one, but it's on its side. And that is because it is a cube root. And what it does is it looks like similar to a square root equation, only instead of, it has that little 3 as the index. That means it's a cube root. That would be with your transformations, what it would look like. The domain and range for this are also negative infinity to positive infinity. And x and y-intercepts are at 0, 0. And then the end behavior, negative infinity for the left, positive infinity for the right. It does go up continuously. It just goes a lot slower than some of the others. But it gets there eventually. You have a big enough x value, it's going to be pretty high. All right, this one should look familiar because you just had a test over it. This would be a what? Exponential. Exponential is going to be y equals b to the x. Now, for this one, I'm not going to be that specific about what that number is, but I do want to talk about how do you know what that number is. It's based off of that point right there. What's that y value? 2. So that means b is 2. So y equals 2 to the x would be my actual equation on this one. Okay? Domain, we know, is negative infinity to infinity. Range is parentheses 0 to infinity. Make sure you use a parentheses at 0 because remember, what is there that dotted line called that's along the x-axis? My asymptote, it never touches that point, therefore it's never actually going to get to 0. That's why we use a parentheses, not a bracket. So therefore, if it never touches the x-axis, do we have any x-intercepts? No, we don't. Y-intercept is always at 0, 1. And then my end behavior, going to negative infinity to the left, it goes closer and closer to that asymptote, so 0. And then to the right, it goes to positive infinity. And then the transformation, y equals a times b to the x minus h plus k. That would be your transformation equation. Okay, again, this next one should look familiar. This is logarithmic. That would be y equals log base b of x. For this particular problem, b, again, is determined by that point right there. If y is 1, what is x? That's how you know. So this would be y equals log base 2 of x. Again, I'm not going to be all that picky. I'm not going to be asking you that specific of a question on that. But next year, especially if you take pre-cal, that would be something you would need to know. All right, domain for this one is 0 to infinity, range negative infinity to infinity. Because, again, there is a dotted line called an asymptote along the y-axis. It never hits the y-axis. So this time we have no y-intercept, but we have an x-intercept at 1, 0. As x goes to negative infinity, it doesn't go to negative infinity because it doesn't go past that asymptote. So we don't have anything for that. But as x goes to positive infinity, it goes to positive infinity as well. The transformation for this, y equals a log base b of x minus h plus k. These next two, these are the ones we're going to be starting after we get back from break. These are rational functions. There are two types. This one is called rational odd. It's odd because my graph is in opposite quadrants. They're diagonal from each other. Okay? So the equation y equals 1 over x is your parent function. If I were looking at the transformations, that would be a over x minus h plus k. The domain for this, so this one's going to be a little bit trickier. The domain is negative infinity to 0, union 0 to infinity. The reason why we have that weird looking thing there is because there are two asymptotes in a rationals equation along both axes. And what it does is it skips over that one value. So when you have two parts of a domain, you connect it with this U symbol that's called a union. Both the domain and the range are going to have that. We will talk more about that when we get into that next unit. But just know on these, the domain and range, so the domain, if I have a horizontal shift, that just changes that number by that shift. If it shifts left 3, that number 0 becomes negative 3. Shifts right 5, that number 0 becomes 5. And then same thing with the range, shifting up or down changes that 0 to be whatever that number is for the shift, okay? X and Y intercepts, there are none. It never hits for the parent function. It never hits the axes because of those asymptotes. And then my end behavior, left and right end behavior is going to 0. All right, for this one, this is your other rational. This is rational even. The equation is y equals 1 over x squared. If you're talking about the parent function transformations, it's a over x minus h squared plus k. The domain, again, has that little weird skip, negative infinity to 0, union 0 to infinity. But the range on this one isn't weird. It's just 0 to infinity. because you'll notice this one is not in opposite corners. They're on the same side of the y-axis. So it's just the top half. The only thing that would affect the range is a vertical shift, and it would just change that number, kind of like on your exponential and all your others. For here, the domain is just like the previous one. X and y-intercepts, again, there are none because there are asymptotes along both axes at this one too. So my end behavior, left and right, is going to 0.